Dear students, welcome to ECA 1 class. Today we are going to discuss Norton Theorem. In the previous lecture, we studied Thevenin theorem, in which we state that any two-terminal DC network can be replaced by an equivalent circuit consisting of solely of a voltage source and a series resistor. In Norton theorem, we have any two-terminal DC network can be replaced by an equivalent circuit consisting solely of a current source and a parallel resistor. Here is the difference between the Thevenin and the Norton is that Thevenin is basically dealing with the voltages and current and the resistor in the series, but in Norton theorem we are dealing with the current source with a parallel resistor. Now let's see the procedure for applying Norton theorem to any electrical circuit. In the first step, let us consider an example with the voltage source and the two resistors. We have RL load resistor. We have to find the Norton equivalent circuit for that shaded region. In the first step, remove the portion of the network where the Norton equivalent circuit is found. Remove RL temporarily from the network. You can see in the figure we have removed RL from the network, and now we have to find the Norton equivalent for that particular circuit. In the second step, mark the terminals of the remaining two terminal network. We marked here A and B. Find Rn. Rn is basically Norton resistance. Calculate Norton resistance by first setting all the sources to 0. All the sources to 0 means if you have a voltage sources in circuit, replace that voltage source with a short circuit. And if you have a current source in the circuit, replace that current source with an open circuit. In our case, we have only one voltage source even, so we replace that voltage source with the short circuit. Here you can see in the figure we have replaced the voltage source with a short circuit. Now we have to find the Norton resistance. Now from the figure you will see that R2 and R1 both are in parallel, so the Norton resistance is basically equal to R1 parallel to R2. In the next step, we have to find the Norton current. Calculate Norton current by first returning all sources to their original position and finding the short circuit current between the marked point. From the figure you will see that the mark points are A and B. We have to find I Norton from that point in order to find the equivalent Norton circuit. Draw the Thevenin equivalent circuit with the portion of the circuit previously removed replaced between the terminal of the resistor RL. So this is basically the Norton equivalent circuit for that shaded region. Okay, now let us solve an example in order to understand how we can apply Norton theorem to any circuit. In this circuit, we have to find the Norton equivalent circuit for that shaded region. In the first step, we remove that RL from the circuit temporarily and mark that point with A and B. In the second step, we have to find the Norton resistance Rn. So in order to find the Norton resistance, we have to set all the sources to 0. In this case, we have only a single voltage source, so we replaced it with a short circuit. Now you will see that R1 and R2 basically are in parallel combination, so Rn is equal to R1 parallel to R2. When we put the values of R1 and R2 in the relation, we get the value of Norton resistance, which is equal to 2 ohms. Now, in the second step, we have to find the Norton current. So, in order to find the Norton current, short circuit that 2 points A and B and find the current through that short circuit. So, we set all the sources to their original position, and from the circuit you will see that all the current will flow through that short circuit and no current will flow through R2. It means we have to remove R2 from the circuit because current follows the easiest path. So easiest path is basically A and B, which is short circuit. So we have a simple series circuit with a voltage source 9 volt and R1. So the current through the circuit is basically equals to the applied voltage divided by the total resistance. In this case, when this point becomes short, R2 to have no effect on the circuit, so we remove R2 from the circuit, so we have only R1. So when we substitute the values into the relation, we get I Norton, which is equal to 3 amperes. Now we have R Norton and I Norton. We can find the Norton equivalent circuit for that shaded region. So this is basically the Norton equivalent for that particular circuit. We have a current source with the value of 3 ampere and the parallel resistance Rn, which is equal to 2 ohm. Place your load resistor to its original position. That's all for today's lecture. Thank you very much. If you have any questions, you can ask through comment box. Thank you.